And look, when I want it to, it doesn't. I don't know why it's doing this. Well, the first thing is we're interested in things like adaptations to training. I'm going to bang it through, bring it back. Right. This is the big area. So we're interested in this because we know that if we're talking about aerobic capability, we're interested in your oxygen consumption. The major factor that governs oxygen consumption is the amount of oxygen that can be transported in the circulatory system. So, we're interested in total hematological response. First point, your plasma volume can increase within 24 hours after exercise. And you can get an increase, which is a sustained increase of about 10%, above the pre-training within 1 to 4 days. So we get quite acute physiological responses in plasma volume. And that's primarily, it's not because you're drinking more fluid, that is because more fluid is being released from the cells into the circulatory system. We actually retain quite a bit of fluid. Bearing in mind that the body is over 60% water, then we've got a fair amount of fluid that can actually be released back into the circulatory system. If we look at why blood volume increases, then primarily the big response in the first couple of weeks is plasma volume. So in the first couple of weeks, when we expose somebody to training and we just look at total blood volume, total, and it goes up, it's not because we've increased red blood cell count. It's not because we've increased hemoglobin concentration. It's because plasma volume is increased. Why though? Why? Why are we trying to, oh no, rubbish term. Biologically, why would plasma volume increase? What's the benefit of having a decreased plasma volume? Sorry, increased plasma volume. In terms of somebody adapting for endurance.
Would it reduce blood pressure?
Exactly, that's what it is. It reduces blood pressure. If you reduce blood pressure, what happens to the pressure being placed on the heart? It reduces. Therefore, we have less stress on the heart. So what happens to the oxygen cost of doing work? It decreases. Oxygen decreasing per length of muscle. Sorry, I'm going to say it again. The amount of oxygen consumed going down for every time muscle changes length that is the primary indication of an endurance training adaptation. But you won't get those big responses. Cardiac output is not going to increase suddenly in a matter of days. Stroke volume is not going to increase in a matter of days. So the easy biological response is, as you start to expose the individual, and we increase things like erythropoiesis because of CO2 production, is that we get a biological release of fluid. The biological release of fluid increases plasma volume to decrease pressure on the myocardium, which therefore allows less stress to be placed on the system. Therefore allowing you to train. After about 2 to 3 weeks, that's when we start to see an increase in red blood cell count. Erythrocyte volume starts to go up after about 2 to 3 weeks. So as much as the data I mentioned earlier on from Pike's Peak, from Greg Levine's group, was showing increases within 6 hours, I did make the point that that is not sustained. You lose that. It's a shock response. Once you get to this value here, about an 8 to 10% increase, the data suggests that actually it levels out. That you don't keep gaining in red blood cell volume. You don't keep increasing erythrocyte count. Because if you keep increasing erythrocyte count, what happens to the viscosity? It increases. The blood gets thicker. So there has to be a natural balance between your erythrocyte count, so the red blood cell volume, and plasma volume. So it will rise and level out. But an 8 to 10% increase is an enormous increase. That's a really big increase. What's quite staggering is to get to that and sustain an 8 to 10% increase as much as you get a fairly acute increase in the first couple of weeks, an 8 to 10% increase can take up to 10 years. Staggering thing is, you'll get a 5% decrease if you stop training for 4 weeks. 10 years to get to 10%, lose half of it in 4 weeks. Because the stimulus has to be sustained. It's not that we just get here, it's we've got to now maintain it. So if you look at the data from Majika's group out in France, Inigo Majika's group shows this nice data on detraining, and they show this loss, very acute loss, within a matter of weeks. So the result, and this is quite fascinating, is if you expand volume of red blood cells and we expanded plasma, because we expanded both of them, the hematocrit score never changes. If you measure it in the initial stages, then of course what happens is, it looks like the hematocrit score's gone down because you've made the blood more viscous, sorry, less viscous because you've increased plasma volume. But once we attain this significant increase, in other words, we get the balance between red blood cell volume and plasma volume, the result is that hematocrit score never changes. Remains constant, goes back to the pre-training levels. You've just got higher red blood cell counts, you've got an increased plasma volume.